Adding and subtracting fractions. Let's say we took 1/4 and tried to add it to 1/2. Well, you can see if we just draw a dotted line through here and cut this into fourths, that 1/4 plus the 1/2 would actually be a total of 3/4. And that's because if we cut that into fourths, we have 2 red slices out of 4 total. And we get that just by multiplying by the same number, so doubling it. So our first step when we add or subtract fractions is just get the same denominator. And then we want to combine the numerators and keep the denominator. So for example, our 1/4 plus our 1/2 became times 2 times 2, we got 2/4, so now they have the same denominator. And we combine our numerators, 1 plus 2 is 3, keep the same denominator, and it's 4. And you can easily see that here, 1/4 plus 2/4 gives us 3/4. And then your last step is always to reduce. In this case, we don't need to reduce because 3/4 is already reduced all the way. Now it's important we know these basic addition subtraction rules for fractions because we can throw letters and variables in there and integers in there, so we can have negative numbers too. So for example, let's say we were doing 7 over 8x minus 3 over 8x. Here we have the same denominator. They are both over 8x. So we can just combine our numerators. So 7 minus 3 we combine. And 7 minus 3 of course is 4. It's 4 over 8x because we leave our denominator the same. And then we have a common factor of 4. So divide it by 4, divide it by 4. And we get 1 over 2x. Alright, now let's try one where the denominators are not the same, but we're still using letters. So for example, if we wanted to simplify 3 over 2y, subtract it from 4 over y, look at your denominator. It's not the same, but you have basically, this is like 1y. So 1 and 2, how do I get that to be the same? I just multiply this one by 2 and by 2, and I would get 8 over 2y. Now these two are the same denominator, 2y and 2y. And now I just think of it as 3 minus 8, because I just subtract my numerators, and it's all over the same denominator of 2y. And 3 minus 8 is negative 5, so it's negative 5 over 2y. I can't reduce that because there are no common factors with the 5 and 2, so it just stays negative 5 over 2y. And we need to remember you cannot add integers or constants, that just means numbers that do not have variables, with numbers that do have variables. Why? Because these are not like terms. They don't have the same last name, so you can't just add them or subtract them. So for example, if we had 2 over 3 minus 3x over 4, we would have to get the same denominator. So 3 and 4, our least common multiple with 3 and 4, if I write them out, 3, 6, 9, 12, oh there it is, 4, 8, 12. 12 is our least common multiple. So I write 12 on the bottom for each of these. It would be times 4, and that would give me 8 twelfths. And how do I get from 4 to 12? Times 3 and times 3, and that would give me 9x. So now I have 8 minus 9x over the denominator of 12. And you cannot simplify this anymore because 8 is an integer or a constant and 9x has a variable. So these have different last names, so it's already reduced all the way. So that's just your final answer. And many people are tempted to say, oh, 8 minus 9, that's negative 1 over 12, or negative x over 12. But again, these are not like terms. All right, let's say a snail traveled 1 1/4 feet in an hour. And then an upside down beetle was chasing it, so it picked up its pace and traveled 3 1/6 feet the next hour because it was so scared of that beetle. How far did the snail travel in all? Wow, that would be fun to watch, wouldn't it? Our words travel in all means that we are doing addition. We're adding up the total distance traveled. So 1 1/4 the first hour plus 3 1/6 the second hour. And then after that 2 hours, how much do we go in all? Let's get the same denominator with our 4 and 6. So 4 and 6, we think 4, 8, 12, 6, 12. Our least common multiple is 12. And how do I get from 4 to 12? Just triple it, or multiply by 3. And then 1 times 3 is 3/12. And then 3 1/6, if I just double the 2, I get 12. Or double the 6, I get 12. And double the 1, and I get 2. So we have 1 3/12 now, plus 3 2/12. Notice our whole numbers did not change. They're still 1 and 3. All we're changing is the denominator of the fraction. Excuse me, snail, I need to write there. Can you move a little faster? Alright, so 1 plus 3 gives us 4 for the whole number. 3 plus 2 gives us 5 for the numerator, and our denominator stays the same. So we have 4 5/12 feet. Rawr. Now sometimes when we add, though, we get a numerator that's bigger than the denominator. So we'll do one of those. That's when we get an improper fraction. So let's say we had 6 1/2 plus 2 3/5. Sometimes it's easier if you just line these up vertically rather than horizontally. That way you have room to work. So 2 and 5, our least common denominator with 2 and 5 is going to be 10. So I write 10 on the bottom. 5 will go into 10 twice. So I get 6/10 there. 2 will go into 10 5 times. So I get 1 times 5 is 5. And just to make this look a little neater, we have 6 5/10 and 2 6/10 that we're adding now. And we get 5 plus 6 is 11/10, and 6 plus 2 is 8. Now 11/10 is improper, so 11/10 is really 10/10 or 1 whole, and 1 left over, so it's really 1 1/10. So if I add that to my 8 there, I have 9 1/10. So anytime you have an improper, you have to make it a proper fraction. So that's really 10/10 plus 1/10, which is 1 1/10. And 8 plus 1 is 9, so it's 9 1/10. Now it can get a little tricky when we're borrowing from a whole number. Now, some people, when they ask to borrow a pencil, they'll say, "Hey, teacher, can I borrow a pencil?" And here's what happens to that pencil. It never comes back. It just flies away in their hands, and who knows where it goes after that. Now, the cool thing, though, is math plays fair. So when math borrows, it gives it back, always. So when borrowing from a whole number, we want to give it back in fractional form. And here's what I mean. If we had 7 2/7 minus 4 9/14, well, number one, we need to get a common denominator. So 7 and 14, it looks like 14 is going to be the winner. So if I double the 7 and double the 2, that gives me 4/14. So I really have 7 and 4/14. Subtract 4 and 9/14, and you cannot take 9 from 4, so you need to borrow from the 7. When we borrow from the 7, we borrow one whole number, and we play fair. We give it back. It's not like you borrowing a pencil from me. And we give back in the form of a fraction. So look at this denominator, this 14. That tells you what type of a fraction you add back. So we add back 14/14, which makes that 4 plus 14 is 18/14. So now it's 6 and 18/14, subtract 4 and 9/14. Now I can take 9 away from that 18. So 18 minus 9 gives me 9 out of 14. And the 6 minus the 4 gives me 2 for my whole number. And that's reduced. So it's just 2 and 9/14. All right, why don't you practice borrowing? Try this one on your own. Let's say we had 8 and 1/2, subtract 3 and 11/12. All right, go ahead and pause the video and try this one on your own. All right, let's see what you got. Well, first off, you should have made it out of 12, and we multiplied by 6 and got 6/12, which is really 8 and 6/12, subtract our 3 and 11/12. And now you can't borrow, you can't take 11 away from 6, so we needed to borrow from that whole number 8, which makes that 7, but we gave it back in the form of a fraction, so 12/12. So it's really 7 and 18/12, subtract 3 and 11/12. 18 minus 11 gives us 7/12. And our 7 minus our 3 for the whole numbers gives us 4. Did you get that? I hope so. Here, go ahead and borrow this pencil. Please give it back.